Pluto made them come all along. Pluto's circle crosses that of another planet. Pluto, the cryptic little planet at the external compasses of our nearby planet group, is working up energy on the planet of space science. Ongoing reports indicate a conceivable experience with Neptune, raising worries among researchers and space fans. Eminent figures like Neil deGrasse Tyson and Michio Kaku have sounded alerts about the ramifications of this grandiose occasion. However, how did Pluto end up on a crash course with its adjoining planet, and what might the divine conflict at any point mean for life on Earth? Join us as we disentangle how something enormous just slammed into Neptune and how researchers have been left stressed by this enormous abnormality. Pluto, once hailed as an undeniable planet, went through a change in its status, being renamed as a diminutive planet because of its particular circle. In spite of this downgrade, Pluto still enthralls and interests the galactic community. Late expectations from regarded researchers like Neil deGrasse Tyson and Michio Kaku have raised worries about Pluto's direction possibly meeting with Neptune's, indicating an approaching string of crashes between the two heavenly bodies, which could have huge repercussions for Earth. Pluto's excursion around the Sun stands out because of its exceptional attributes. Inside our nearby planet group, its circle is particularly extended, spreading over a stunning number of years. Since its discovery in 1930, Pluto still can't seem to finish a full revolution around the Sun. Adding to its persona is the highly lengthened shape of its circle, a departure from the more round ways followed by the major planets. Besides, Pluto's circle veers off by 17 degrees from the ecliptic plane, giving its way a more extreme grade contrasted with different planets. The mix of Pluto's tendency and its elliptical orbit presents layers of complexity to its orbital pattern. One remarkable perspective is its occasional crossing point with Neptune's circle. For something like 20 years during each orbit, Pluto ventures closer to the Sun than Neptune, resisting assumptions based on their particular situations in the nearby planet group. Digging further into Pluto's circle, it's captivating to take note that it's not a perfect circle, but rather an elongated orbit resembling more of an oval shape. This remarkable orbit results in huge varieties in Pluto's distance from the Sun throughout its journey. At its nearest approach, Pluto comes within around 30 astronomical units, AU, of the Sun, while at its farthest point, it reaches more than 49 Australian dollars away, twice the distance of Neptune from the Sun. Also, Pluto's circle is leaned at a point relative to the orbits of the significant planets in our planetary group. This tendency not only adds to the complexity of its orbit but also plays a significant role in its interactions with other celestial bodies, especially Neptune. When Pluto encounters Neptune, their gravitational pulls impact one another, changing their directions over time. The unpredictable dance among Pluto and Neptune highlights the unique nature of our planetary group. While Pluto was once considered a solitary vagabond in the outer reaches, its nearby experiences with Neptune feature the interconnectedness of celestial bodies, each applying gravitational forces that shape the paths of others. Lately, advancements in observational technology have allowed cosmologists to track Pluto's movements with greater accuracy. This has led to a deeper understanding of its orbit and its potential implications for the stability of the outer solar system. While the probability of an immediate crash between Pluto and Neptune remains low, the chance can't be entirely discounted. Continuous observation and study by the astronomical community are essential. Regardless of its minor size and remote location, Pluto continues to command attention and interest among researchers and fans alike. The question arises, why hasn't there been an accident between Pluto and Neptune? The answer lies in the gravitational pull from other planets. Cosmologists began concentrating on Pluto's path not long after discovering it, and its course perplexed them. Unlike most planets that stay near the same plane as they orbit the Sun, called the ecliptic plane, Pluto stands out with its steep angle and oval-shaped orbit. The mystery deepened when they realized Pluto's path crossed Neptune's. In spite of these intricacies, Pluto's orbit remains stable, demonstrating the intricate mechanics of space. Figuring out how three celestial bodies, like Pluto, Neptune, and the Sun, move and interact gravitationally is a major challenge. It's like trying to predict where they'll go based on where they start and how they pull on each other. For Pluto, this challenge reveals how its orbit, Neptune's orbit, and the sun's position all work together. Terms like libration and oscillation help researchers tackle this infinite riddle. As oscillation is vital for keeping planets in their orbits, when Pluto crosses Neptune's path, it's something like 90 degrees away, holding them back from crashing. Oscillation ensures that when Pluto approaches Neptune or other large planets, it's well above their path, reducing the chance of a collision. The oscillation, named after researchers von Zeipel and L.V., explains why Pluto's orbit appears strange yet remains consistent over time. Despite the confusion in space, certain patterns and rules keep things together. These principles maintain Pluto's orbit stable, preventing crashes with Neptune or changes in its path. The concept of orbital chaos, illustrating how a celestial body's path is highly sensitive to where it starts, is well demonstrated by Pluto. Even minor changes in its position or speed can disrupt its orbit. Over the years, researchers use computer simulations to figure out how Pluto moves in space. These simulations utilize complex math to model how Pluto interacts with other space objects, like Neptune. By tweaking these simulations just a bit, astronomers can see how slight changes can adjust Pluto's path. In the late 1980s, these simulations found something intriguing about Pluto's orbit. Despite factors that should stabilize it, Pluto's orbit can still be unusual. Just a slight difference in where Pluto starts or how fast it's going can lead to significant changes over many years. Yet even with this disorder, Pluto's orbit remains stable for an incredibly long time, like billions of years. This suggests that although Pluto appears chaotic, its journey around the Sun follows some kind of order. Predicting what will happen with planets like Pluto, which have irregular orbits, is difficult. These systems are so unpredictable that it's hard to know what will occur over time. Simulations help us learn about what could happen, but they also show us that we can't predict everything perfectly. These models require precise starting points and mimic complex dynamics. Indeed, even a small error can lead to completely different outcomes, making it challenging to make accurate predictions. Understanding Pluto's orbit is significant, especially when we consider whether it may collide with Neptune in the future. This knowledge helps us understand better how our solar system works. Pluto's orbit teaches us how orbits that seem unstable can adjust based on gravity and how things move in space. It's crucial to keep observing and studying these phenomena so we can understand where we fit in the universe. When we explore space, we find that things can be unpredictable, and Pluto's orbit is a great example of that. Pluto's orbit isn't like those of the other planets. It's more oval-shaped, which means it's not a perfect circle. Sometimes it even comes closer to the Sun than Neptune does. This can make things precarious because Neptune is also out there cruising along its path. There's a small chance that Pluto and Neptune could collide eventually. Despite its odd orbit, Pluto manages to keep its distance from Neptune most of the time. This is due to something many refer to as gravitational forces. Gravity is like an invisible force that pulls things toward each other. So even though Pluto and Neptune might seem like they're on a collision course, their orbits are carefully arranged, moving under the influence of gravity. Pluto's orbit teaches us that space is full of surprises. What seems chaotic at first can be a delicate balance of forces. By studying Pluto's orbit, researchers gain insights into the complex mechanics of our solar system. This ongoing observation and investigation are fundamental for expanding our knowledge of the universe and our place within it. Imagine if Pluto and Neptune impacted. It would be a vast event, sending shockwaves through our understanding of the solar system. While we've made progress in understanding space, the situation shows that we still have a long way to go. Studying what large planets mean for Pluto's path provides significant hints about how our entire nearby planet group works. It illustrates that where every planet is and how it moves can alter the paths of other things in space. Even though space is complicated, some leading researchers are concerned that Pluto could collide with Neptune. This makes them wonder why this could happen, even if it seems improbable. Neil deGrasse Tyson, a prominent space researcher, has interesting thoughts about Pluto. He believes that renaming Pluto as a dwarf planet, not a major one like Earth, is a step forward. He thinks we are continually learning new things about how things move in space. Tyson sees Pluto's unusual path as a sign that there's still a lot we don't know. He believes that the mysteries of space make studying it so amazing. He also understands that significant events in space, like Pluto's renaming, get people interested in astronomy. Tyson wants to help people understand the cool and sometimes strange things about how space functions. He thinks it's essential to discuss how space mechanics can surprise us. Tyson works with various researchers to warn people about the potential risks of Pluto's unusual path. After studying Pluto extensively, he is concerned that it could collide with Neptune one day. He says this could cause enormous issues for our entire solar system. A collision between Pluto and Neptune would be an interesting and serious event. It would release a lot of energy and could break apart Pluto. Fragments from the collision could fly around space and hit other planets and moons. Neptune could also feel the effect and change how it moves. Eminent theoretical physicist Michio Kaku believes that if Pluto and Neptune impact, it would be an unprecedented and rare cosmic event. Kaku views such an event as a crucial opportunity for researchers to learn about the dynamics of our nearby planet group. He suggests that while the probability of such a crash is very low, the potential insights gained from studying such an extraordinary event could be invaluable. Kaku emphasizes that this wouldn't just help us understand the mechanics of planetary orbits, but also provide a deeper understanding of the formation and evolution of our solar system. He also believes that the scientific community should continue to monitor Pluto's orbit closely to ensure that we are prepared for any unexpected changes. As we advance our observational technologies, Kaku argues that we are continuously uncovering new aspects of our nearby planet group that challenge our current understanding. Despite the low likelihood of a collision, Kaku advocates for ongoing research and vigilance, as even the smallest changes in our celestial neighbors' orbits can have significant implications for our knowledge of the universe. To further appreciate the complexity of Pluto's orbit, it's essential to understand the various forces at play within the solar system. The gravitational influence of other celestial bodies, like the gas giants Jupiter and Saturn, also affects Pluto's path. These giants exert a substantial gravitational force, which can subtly alter the trajectories of smaller objects like Pluto. This is a prime example of how interconnected the solar system is. Even distant bodies can influence each other's orbits through gravitational interactions. Jupiter's immense gravity, in particular, can send ripples through the orbits of nearby objects, occasionally bending their paths in surprising ways. In addition to gravitational interactions, the presence of other trans-Neptunian objects, TNOs, and Kuiper Belt objects, KBOs, presents extra layers of complexity. The Kuiper Belt is a region of space beyond Neptune populated with numerous icy bodies and dwarf planets, including Eris and Haumea. The gravitational influence of these objects can contribute to the perturbations in Pluto's orbit. Studying these interactions helps researchers understand not only the dynamics of Pluto's orbit, but also the broader architecture of the outer solar system. One captivating aspect of Pluto's orbit is its relationship with the solar wind, a stream of charged particles emitted by the Sun. Although Pluto is far from the Sun, the solar wind still influences its atmosphere. When Pluto's orbit brings it closer to the Sun, its atmosphere can expand due to the increased solar radiation, making it become more dynamic. This connection is essential for what makes Pluto such an intriguing object of study. The way its atmosphere responds to solar changes provides insights into how distant celestial bodies interact with their local cosmic environment. Moreover, Pluto's relatively recent flyby by NASA's New Horizons spacecraft in 2015 provided a wealth of data that continues to impact our understanding of this distant world. New Horizons captured high-resolution images and gathered various measurements of Pluto's surface and atmosphere, revealing stunning details like the presence of vast ice plains, towering mountains, and even potential signs of cryovolcanism. These discoveries have reshaped our perceptions of Pluto, showing that it is a dynamic and geologically active world rather than a static frozen artifact. The implications of Pluto's complex orbit and its interactions with other celestial bodies extend to our understanding of celestial mechanics. The exploration of such interactions contributes to the broader field of dynamical astronomy, which investigates how objects move under the influence of gravity. By analyzing the complex dance between Pluto, Neptune, and other planetary system bodies, researchers gain insights into the principles governing orbital mechanics and stability. This knowledge is crucial for predicting the future movements of celestial objects and understanding the long-term evolution of planetary systems. In terms of planetary defense, studying objects like Pluto is also relevant. While Pluto itself poses no threat to Earth, understanding the behavior of small bodies in the solar system helps researchers develop strategies for monitoring and mitigating potential threats from other objects. The principles learned from studying Pluto's orbit can be applied to tracking near-Earth objects, NEOs, and predicting their future paths, which is essential for a broader effort to protect Earth from potential impacts by asteroids and comets. The scientific community remains vigilant in its observation of Pluto and other distant objects. Future missions and ongoing observations will continue to refine our understanding of Pluto's orbit and its interactions with the planetary system. Upcoming space missions, such as potential missions to other Kuiper Belt objects, will provide further data that could reveal more about the early solar system and the formation of planetary systems. In addition to its scientific significance, Pluto's story also highlights the role of public engagement in astronomy. The renaming of Pluto as a dwarf planet ignited worldwide interest and discussion, showcasing how scientific discoveries can capture the public's imagination. Educational programs and outreach activities focused on Pluto and similar celestial objects help foster a greater appreciation for the wonders of the universe and inspire the next generation of scientists and explorers. Overall, the investigation of Pluto's orbit and its potential interactions with Neptune offers valuable insights into the dynamic nature of our planetary system. By continuing to explore and monitor these distant worlds, researchers enhance our understanding of celestial mechanics, planetary formation, and the broader cosmic environment. The ongoing research into Pluto and its connections with other planets underscores the complexity and interconnectedness of the solar system, revealing a universe that is both captivating and ever-evolving.